A load cell, as important as it is, really isn't that complex in design. It's a simple hydraulic device with only one moving part, a diaphragm. Now this diaphragm can transmit a tension or compression load in pounds to a local or remote pressure gauge. Because its accuracy and sensitivity are superior to other types of load indicators, load cells are a must in our business. Basically, there are two types of load cells that we use, the compression system and tension system. All load cells are compression measurement devices, but with the addition of auxiliary hardware, it has the additional capability of measuring tension loads with extreme accuracy. Tension loads can have a number of different attachments and capacity limitation. For example, the latch hook with capacity limitations up to 300,000 pounds. The swivel latch hook with capacity limitations up to 60,000 pounds. The eye-nut with capacity limitations up to 25,000 pounds. Shackle with capacity limitations up to 250,000 pounds. Clevis with capacity limitations up to 25,000 pounds. There are two types of pad eye. The first has capacity limitations up to 25,000 pounds, while the second has capacity limitations up to 300,000 pounds. Now, on the rig, most of you are familiar with the tong torque indicator, or load indicator. Well, these two pieces of equipment might use a load cell very similar to this one. Periodic checks need to be made on the load cell to see if it's working properly. After you've removed the load cell from the piece of equipment it's being used with, take it back to the mechanic shop and give it a good check. The first thing you need to do is remove this small screw from the load cell. This allows the hydraulic fluid to drain out. Be sure to use something to catch the fluid. Don't just let it run onto the floor. Once the fluid has been drained out, place the cell into a vise with brass insets. This protects the cell from being damaged by the teeth of the vise. Then take your Allen wrench and remove the two cap screws from either side of the cell. Once you've done that, the end will easily come apart for your inspection. And now that you have it apart, be sure to remove the compression ring from inside the load cell. By the way, this ring should never be used again. Inside the cell, you need to take your Allen wrench and remove the internal socket screw from the piston. This should allow the piston to be rotated with a hammer and punch, like this. Now that you've got the internal piston loose, it should come right out, and the load cell should be completely disassembled. But wait a minute, you're not through yet. Now that all the parts are disassembled, you need to remove the large and small O-rings from the piston. The O-ring seals need to be cleaned and inspected for any type of nick or binding marks. If you have new O-rings, It's a good idea to use them instead of the old ones. Be sure to check the small O-ring as well. The load cell body also needs to be cleaned and inspected for any type of wear, such as nicks or cracks in the sidewall. This can cause an improper reading from your load cell to your indicator. If there wasn't anything wrong with the load cell during your inspection, you're now ready to reassemble the load cell. Reassembling is basically the same as disassembly. Remember, the socket hole on the piston must be a perfect match before the socket screw can be put back in. Be sure to install a new compression ring, and by all means, don't use the old one. Once that's completed, screw the load cell cap back onto the cell. The alignment marks on the load cell must be lined up with the holes on the load cell body so that the cap screws can be put back in. If everything seems to be back in its proper place, then your inspection is complete. It's just that simple. Now, the load cell you're probably most familiar with is the E80 sensator on the deadline anchor. It has to be by far the most important load cell on the rig. Because it's so important, periodic checks need to be made on the load cell. So with the blocks empty, check the cell gap to see if the gap is approximately 62 hundredths of an inch, or 16 millimeters. If the cell is less than 50 hundredths of an inch, or 13 millimeters, you need to check the sensator. Disconnect the hose or hydraulic weight indicator for fluid leaks. If you find that leaking fluid is not your problem, and the sensator still is not working properly, the sensator should be removed from the anchor and taken to the shop for inspection. This means the E80 sensator must be dismantled. Place the load cell in a vise so it's easier to work on. Then remove the check valve from the junction block. This junction is used in loading fluid into the load cell. Check the rear of the valve to see if any dirt or grease got in during one of your previous loadings. Now remove the J900 connection from the block and make the same inspection you did for the check valve. If the dirt doesn't seem to be your problem, take a standard screwdriver and remove the top junction block. This connects the hose running from the junction block to the main bladder inside the diaphragm itself. Once the junction block has been removed, you'll be able to see the hose where it connects with the bladder. Remove the hose so you don't damage it in any way. This will free the top bell housing for further disassembly. Take your socket wrench and a 7/8 inch socket and remove the outer bolt from the bell housing. After several bolts have been removed, loosen the remainder of the bolts and remove the spacers from the top half of the housing. Now you're ready to remove the upper bell housing from the main assembly. Under the housing, you'll find a short elbow joint and the other end of a fluid hose connected to the main bladder. Remove the hose from the joint and make a visual inspection, checking for wear or leaks. If you have any problems with the hose, replace it with a new one before reassembling the sensator. Now at this point, you can remove the remaining bolts from the bottom half of the sensator, just like you did for the top half. Since you have the bolts out, check to see if they show any signs of cracking or wearing. Once all the bolts have been removed, you're ready to remove the bladder and assembly from the unit. Grab hold of the assembly and lift straight up. This will expose the bladder for inspection. Check in this area for wear or pinhole leaks. These small leaks can cause an improper reading in your load cell. Now that you've inspected the bladder, remove the plunger from the base of the unit. By the way, the plunger is used to compress the diaphragm inside the load cell. Down in the bottom of the base, many problems do occur. For example, the base sometimes fills with oil or dirt. This causes the two drain holes at the bottom to become clogged. So make sure that the base is cleaned, and check the drain holes to see if they're clear and unclogged as well. Now that you've removed the bell housing from the vise, take the bladder and put it in the vise. The first thing you need to do is remove the screws from the bladder with an Allen wrench. Once the screws have been removed from the diaphragm assembly, the diaphragm should come right out. Check the diaphragm to see if any leaks occurred, or if any defects were caused in the ring grooves when it was crimped down during the last servicing. Any defect in the ring groove whatsoever will cause a leak and an improper reading. Take your time, and be sure to check it well. Also check the ring groove area on the diaphragm assembly for any sharp areas. This could cut into your diaphragm and cause leaks. Well, it looks like the E80 is totally disassembled, so I guess you think you're through, right? Wrong. Now it's time to reassemble the E80 and see if it's going to work. When you begin to reassemble, see that the diaphragm is put into the top half of the diaphragm unit, and be sure the diaphragm fits the ring groove correctly. Make sure it wasn't over or undercut before you put the outer ring on. Go ahead and put all the screws back in the assembly and tighten down with your fingers. Now, take your Allen wrench and snub up one of the screws. From that screw, go to the opposite screw 180 degrees and tighten it down, like in this diagram. This allows the diaphragm to be compressed equally all the way around. Now that the diaphragm has been seated properly in the diaphragm assembly, go ahead and tighten the remaining screws in a crisscrossing pattern like you did before. Now the bottom of the bell housing should be placed back into the vise and the plunger placed inside of it. Be sure that threaded holes on the assembly lie in between the non-threaded holes on the bottom half of the unit. This allows the diaphragm to work with opposing action. Once the holes are aligned, place the top half of the unit onto the plunger and align the threaded holes on the top with the unthreaded holes on the bottom. Before you do anything else, take your hose and screw it into the elbow joint and align it so that it won't be damaged when you put the top half of the unit on. The hose should be screwed in and then looped back over itself like this. Now this is designed so that the curvature of the hose keeps itself off the diaphragm and away from possible damage. Once you feel that the hose has been aligned properly, you can begin replacing the spacers back into the unit. Go ahead and put the bolts in and connect them to the lower housing. Now that the diaphragm assembly and the lower bell housing have been connected, remove the hose again from the diaphragm. Take Teflon tape and wrap it around either end of the hose threads. to ensure a good tight seal. Now, screw the hose back into the elbow joint. Making sure the hose is looped back over itself. Take the upper bell housing and place it onto the unit. Run the hose out through the opening in the front, where it will be connected to the junction block on the outside. Attach the hose to the junction block so the hose won't fall back inside the unit. Now, place the remaining spacers into the unit and bolt them to the upper bell housing. Be sure the upper and lower bell housing are parallel to each other, and then tighten all the bolts down securely. Using a standard screwdriver, connect the junction block into the upper bell housing. Take the Teflon tape again and wrap the end of the check valve and screw it back into the junction block. Now, tape the J900 disconnect just like you did the check valve. And screw it into the other half of the junction block. Now that the disconnect is in, reassembly is complete, except for replacing the sensator back into the anchor. As you know, Sedco is one of the leaders in the oil industry. One reason why is the way we can come up with new ideas and the way we're able to put them to use. On the Sedmeth 701, the engineers came up with a new idea that involves the E80 and the deadline anchor.
I've known of instances where leaks have occurred and it's caused problems. We put a little device on our load cell here just to warn the driller that his gap here is getting a little too low there. Normally the driller checks it regularly, periodically. You've got to check it, but let's face it, anything could happen at any time. So we put this little safety device on here. Basically what it does is, it's a little micro switch here, and if this should happen to, say, move closed to the closed position or towards the closed position at any time suddenly, then this top part has to move up. It trips this little switch here, which in turn sounds an alarm at the driller console. He knows automatically then that something has happened.
This has just been a brief description of how to disassemble and reassemble load cells in the field. In the next part of this series, we'll cover the care and maintenance of the load cell indicator. So if you have any questions or problems, just refer to your technical manual or contact the manufacturer for help. They are more than happy to help you.